Welcome to today's recorded webinar on the vSAN storage technology. That's as a technical overview of vSAN with the Azure VMware Solution. My name is Chris Willingham. I'm a staff cloud solutions architect here at VMware. I'm joined by Matthew Webb, who's also a staff cloud solutions architect here at VMware. We both cover the Azure VMware Solution, and we'll be talking to you today about specifically the components of it. But to start, we're going to introduce what is the Azure VMware Solution, just as a quick overview. First, we're in this hybrid cloud era that allows us to build agile data centers that span physical locations. And it allows us to have efficiency and simplicity in terms of how we operationalize and use the cloud services. The Azure VMware Solution is VMware enterprise capabilities delivered as a native Azure service. It's engineered by Microsoft, validated by VMware, it's sold and supported by Microsoft as another Azure service. And so the Azure VMware Solution is an Azure service running the VMware SDDC components on the Azure bare metal. It allows us to take advantage of the on-demand capacity and flexible consumption models of the cloud, while still maintaining the operational consistency with your on-premises operations. So inside of the Azure VMware Solution, we have vCenter, managing the vSphere environment, the vSAN environment. We have NSX for network virtualization, a tool called HCX that allows us to do network extension and application migration from your vSphere-based on-premises environments, bringing those into the Azure VMware Solution, and then bringing those VMware-based workloads adjacent to your other Azure services, such as Azure Active Directory, Azure SQL, Azure Machine Learning, and artificial intelligence tools. It allows us to integrate this directly with the Azure portal, also using Azure Resource Manager. And HCX allows for seamless, large-scale workload portability. We can bring hundreds or thousands of virtual machines without having to change their identity, including their IP address, their MAC address, or their format, and bring that into the Azure VMware Solution environment and allow you to get direct access from there to the native Azure services throughout the global Azure footprint. A number of use cases that we have customers realizing with the Azure VMware Solution are things like application modernization. So because of the proximity to those Azure services, workloads that were traditionally hard to reformat or refactor can be brought adjacent to those other Azure services, and the data inside of those can then be consumed by other Azure services. Allows you to standardize your Kubernetes platform, perhaps using Tanzu, perhaps using another platform that's vSphere-based. You can run that inside of the Azure VMware Solution as well. Cloud migrations, so consolidating, retirement, or right-sizing of your on-premises data centers allows these workloads to be migrated into a VMware-based environment without having to reformat, refactor, or modify that. Extended security updates. Perhaps you have older workloads that eventually you'll retire, but they're running Server 2008 or Server 2012. This allows you to bring those workloads into Azure and get the advantages of Azure, including the Azure hybrid benefit and extended security updates for those Server 2008 and SQL 2012 and 2008 workloads as well. And then on-demand capacity, the ability to procure additional hardware without having to procure additional hardware. You can bring workloads to the cloud and burst that out as needed for both the data center workloads and then also things like desktops. We have many customers running Horizon and Citrix inside of the Azure VMware Solution and allowing their customers to burst for additional workloads, move those workloads to the cloud, provide disaster recovery for your end user computing suite, and then have proximity to your cloud applications, including Office 365 and Microsoft 365. And then we can complement or replace existing disaster recovery mechanisms as well. We integrate with Site Recovery Manager, as well as third-party tools such as Jetstream and Zerto to allow for reduction and optimization of disaster recovery costs. So the 5 major use cases: application modernization, cloud migrations, data center extension, cloud virtual desktops and EUC, and disaster recovery, come from the synergies of the Azure cloud and the VMware enterprise capabilities. So as we dive a little bit deeper into the storage, I'm going to turn this over to Matthew to talk about how do we deliver that.
Thanks, Chris. Yeah, so now that we've had an overview or maybe a reminder what AVS is, Today's primary topic is what is the storage that drives the solution? So we talked about how AVS is a software-defined data center that runs vCenter, vSphere, NSX, and vSAN, as well as HCX. vSAN is the underlying storage technology for AVS. We do have other storage options, and we have more coming online as we continue to age in the solution. For example, we'll have a future webinar over Azure NetApp Files, which can be a supplemental data store to vSAN, but you get vSAN storage in the node. So for example, like we have AV36, AV36P, AV52, all of those have SSDs that are inside the host itself. And that is what vSAN uses to give you storage for your virtual machines. So vSAN is hyperconverged infrastructure, and there was this massive shift in the industry in the early 2010s, like 2012, 2013, when HCI started really growing at a massive scale. So if you're familiar with storage, we've been doing storage for a long time in really black boxes like SANs that house a bunch of disks. And what we've been doing in that storage array is we've been doing RAID, which is redundant array of independent disks. So we stripe the data across drives within that SAN. With hyperconverged infrastructure, we're doing RAIN instead of RAID. So instead of striping it across disks, we're striping it across nodes, so redundant array of independent nodes. So we use these SSDs that are within the host, and we disperse the data so that if a host were to fail, my VMs continue to operate and have accessibility to storage, which is the most important point. vSAN is different than like a clustered data store. It's a distributed object store, and so that gives us a lot of scalability. For example, vSAN, if you were to deploy it on premise today, can go up to the maximum of 64 nodes in a cluster, 62 nodes in a cluster, which is very expandable. So every time we add a node, we add storage capacity, and every time we add a VM and we add a storage policy to it, we make sure that we disperse that data across multiple nodes to maintain resiliency. The last thing I'll note is, to the object store part of vSAN is that it is per object. And one of the powerful aspects of vSAN is that we can do storage policy-based management. You'll hear this referred to as SPBM. What that does is we can apply resiliency policies down to the per VMDK level. So if you're familiar with older, storage, you basically carve out your RAID groups and you present those as data stores to the vCenter. And the features and attributes of the data store is what gets presented up. We can add features and attributes to a per object level. So like if I wanted to say run a VMDK on a RAID 10 type of profile, and then the database on a RAID 5 or RAID 6, I can do that. I can select those storage policies for each individual object, which we'll see in a demonstration. So let's talk about a couple of the services. So one thing to keep in mind with Azure VMware Solution is it is a managed service, right? And so if you're familiar with vSAN or even with other tools like NSX, there are all sorts of features that you can use in different deployments. These are the specific features that AVS deploys and is configured for you. So deduplication and compression is enabled. And of course, that is a space efficiency capability, and it is both on. So deduplication and compression are enabled. Typically what we do in sizing, me and Chris work with customers all the time to get their VMs and understand their requirements. And we definitely look at storage as one of those requirements. We add, in our sizing estimates about 1.5x in most cases of dedupe and compression. And based on phone home data, when you're part of the CEIP program, we actually see that over 71% of our customers get that efficiency, and some get more and some get less, right? So it's a pretty good number to go off of. But I've seen customers at 2 and 2.5, so it's a relatively conservative estimate. Times when you can't expect about 1.5x is when you have those things that are already not really dedupe or compressible, right? Video files, large image files, GIS information. So just keep that in mind. If it's just general data, 1.5x is usually a good number to go off of. Data at rest encryption is enabled, and this is an important security feature. We now have two options. If you wanted to have Azure manage the keys, they'll use it in the Azure Key Vault, and they manage the keys for the data at rest encryption. And if you wanted to manage your own keys, that is now available. It was released within the last couple of months. But all clusters by default are encrypted, when they're created, and these features are turned on when you deploy the solution. One of the great things about vSAN, you'll see this in the demonstration, is the integration into vCenter, right? So like everything is in one UI when it comes to managing your virtual machine, all the way down to the storage layer. So when we jump into a demonstration, we'll see, I can go to the host view, I can see the IO and throughput and latency on a host. I can go to the individual physical disk and look at what performance is coming off of that disk. And I can also go to the cluster level view and see, what performance is happening at the cluster level. For me, that's cool. That's fine and everything. What really stands out is the higher level metrics. Keep in mind, when you're using vSAN, you see end to end the path of IO. We can see all the way into the guest OS using VM tools, all the way to the backend physical disk. So, most storage arrays will report, when I received the IO, this is what I did with it. This is my latency metric. This is how much IO I received. In vSAN, we can report all the way from when the guest OS initiated that write or that read, how long it took to respond to it, not just when vSAN received it. So we have end-to-end monitoring capabilities with vSAN, which are quite powerful for troubleshooting and also monitoring capabilities. Now, keep in mind, since this is a managed service, you don't have access directly to make storage policies. So Microsoft and VMware develop storage policies that are all you'll ever really need. So there's storage policies in vCenter already for you to consume. If you wanted to change your cluster default storage policy to one of the storage policies that have been pre-made, like for the most common example is you're going to start off with an FTT1 mirroring and say you want to go to FTT1 erasure coding for better efficiency purposes. We'll talk about erasure coding and what efficiency we get out of that here in a moment. But let's say you wanted to make that change. You would actually go into the Azure portal and go to set cluster default storage policy, or go change all your VMs to that policy as well. That's all going to be within these run commands in the portal. And when I jump in there, I'll make sure to stop by that section so you can kind of see that those settings and where you would find them. So let's talk about some of the most important settings when it comes to storage policy. Most of it has to do with how the data is laid down and how resilient it is, right? So let's talk about FTT settings and what FTT means. So FTT stands for failures to tolerate. It means how many node failures, because that is our failure domain, is a node, can we withstand and keep availability and accessibility of the data. So with an FTT1, that's saying that we can withstand one host failure. This is where our 3 node minimums for AVS come in. To be able to do vSAN with at least an FTT of 1, we need 3 hosts. And that's because you need to have 2 places to put the data and 1 place to put a witness. So if you're familiar with any other clustering technology, it's always the power of 3, right? You've got 2 for full copies, and then you usually have a small witness or quorum file that acts as a traffic cop, so it can develop quorum with the available data and make sure that we don't have a split brain scenario. If just 2 pieces without a quorum were available, we could potentially have just a network server and a split brain scenario could occur. So that's where the 3 node minimums come in. And that's what the witness file is for. Keep in mind that the witness is not just dedicated to a tile node. It's a small file that's put on a host. And so, for example, here on this slide, we're seeing data witness. The next VMDK could be witness data, right? So vSAN works to build up the capacity in an even fashion across all nodes in the cluster. And the witness is a small, usually 4 megabyte file to maintain quorum. So this one's rather easy. We are using RAID as a terminology almost in a way to bring in the old concepts because they are relatively similar, but we don't use RAID. This really is RAIN, so keep that in mind. This is more like a RAID 10 than a RAID 1. So as more objects get created, for example, like if I made another VMDK, we could actually start with data on host 3 and then another data on host 4 and then witness component on host 5. So again, even though it says RAID 1, it's more like a RAID 10 concept in action. So now we move to erasure coding. So, why do we have erasure coding? Just the same reasons why you had RAID 10 versus RAID 5 or RAID 50. Doing a parity bit calculation or erasure coding the data allows us to get away, do more with less, essentially. So, it's a 30% savings with RAID 5 and 50% savings with RAID 6. So keep in mind, like if you were to put that in practical purposes, if I had a RAID 1 mirrored object like a VMDK, and that VMDK is say 100 gigabytes in size, then on raw disk, it's actually 200 gigabytes. If I were to do say 100 gigabyte VMDK on FTT1 erasure coding, the RAID 5 setup, it's actually 133 gigs on disk. So you can see how doing RAID 5 has a better storage efficiency than RAID 1 or FTT1 mirroring. There are host minimums when it comes to doing these erasure coding policies. So RAID 5 requires 4 nodes because it is a fixed 3+1 stripe. So in this scenario, you can see the parity bit is striped across 4 hosts. Moving on to RAID 6, similar concept, but this is dual parity. Now instead of just having an FTT1, it's actually FTT2, but we're still doing erasure coding on top of it. The benefit of this is that we can handle 2 whole host failures. Like in this scenario, I could lose host 1 and 2 and still maintain accessibility and availability of the data. So if the VM resides on one of those hosts, HA kicks in, and once HA kicks in, it can still see the data and the VM can operate. So this is a 50% reduction over its correlating mirroring component. So if you did FTT2 mirroring, it would be 50% more capacity than if you did FTT2 erasure coding. So again, these really make a huge difference when it comes to storage capacity. And oftentimes I'm asked, what is, the best storage policy to start with? I always lean towards the erasure coded storage policies first until something in monitoring shows you that certain VMDKs need more performance than these. So there's a storage benefit, capacity, efficiency benefit, but there is a performance hit. Most customers will never notice this because this is an all-flash system. Today with the AV36, we have NVMe in the cache tier, and in the AV36P, we have NVMe in the cache and capacity tier. These are all flash systems and are highly performant. So let's talk about that performance hit so we can, kind of understand what's at play here. If you're familiar with RAID and storage, this is more of a review because the same things apply. So there is something called IO amplification that happens when you have writes happen to a system that is trying to maintain multiple copies for availability. So for example, RAID 1, FTT equals 1, one write equals 2 writes. So one IO is actually 2 IOs in total. So you can see how that's a 2x penalty. So that makes the total IO, the backend IO, much higher. Again, this is all flash system. This is not the days of spinning disk where we were counting IOPS in the hundreds or even sometimes with SATA drives, 60 or 80 IOPS per disk. We're comparing this now to SSDs and NVMe SSDs that are 3, 4, 5,000 IOPS per disk, right? So that's why I'm again going to recommend if you have the proper node count, default to erasure coding, see how things go. And then, you have all the monitoring capabilities. If you notice latencies increase on specific VMs or even specific VMDKs, you have the power through storage policy-based management to go change the storage policy for those specific VMDKs. So if I ran like RAID 6 and that 6x IO amplification was too much for that virtual machine, I could go change that to a mirroring policy. So I have about half of the IO amplification. So going through the rest of the IO amplification, RAID 1, FTT1, One write is 2 writes. RAID 1 FTT2, 1 write is 3 writes. RAID 5 FTT1 is 1 write is 4 writes because there's a parity bit calculation, and then RAID 6 has the biggest IO amplification of 1 write is ends up being 3 reads and 3 writes. So to make that calculation. So one thing to keep in mind is that vSAN has a slack space requirement. As long as you work with Microsoft or VMware, we always include this overhead into our sizing. So when we make a suggestion of amount of nodes that you need, we're automatically taking in that 25% slack space. It is in the AVS SLAs that you maintain that 25% slack space. So there are a number of runbooks and code out there to set some alerts for your new instance that you set up. And one of the alerts that some of these runbooks do is tell you have an alert if you go over this amount. If you don't run those runbooks, I would suggest manually making an alarm within the portal to make sure that you maintain that slack space. So you know, okay, I'm running up to that 25% slack space overhead. I need to go ahead and add a node to maintain the SLA for AVS. And some of the reasons why we need that slack space is like storage policy changes. So for example, like you see here in the slide, let's say I have an FTT1 mirroring component and I need to change it to erasure coding. It creates the new parity bit calculation and copies the data before it deletes the old data. So we need that overhead for these kind of changes that will happen and natively within vSAN, as well as things that just make vSAN run. So that's why we have that 25% slack space, and that's why we've got it as a requirement in the SLA. There is some integrated health alerts within the AVS vCenter. So if you go to the monitoring screen of the cluster view, you'll see the Skyline Health. Most of this stuff is just good to know. A lot of this is around hardware and network and physical disk, and that is not your responsibility, but it's good to have visibility into it just in case something were to arise. If something does come up, Microsoft has plenty of monitoring and code to look for these things that usually they will catch it before you catch it yourself. Matter of fact, Chris and I in our lab, we see it happen all the time where I'll get an email notification from the Azure portal saying, hey, we noticed something wrong with your host and we're actively addressing it. And usually what that means is they're throwing a new host into our cluster and then taking out what they know, that host that had some sort of problem so that they can troubleshoot it. So you may not be in this interface as much to monitor hardware, but it is there, and it does have things like looking for latency in disks. One of the things that happens in physical disks before they go out, sometimes they have really wonky latency characteristics, and there's a lot of ML that was put behind this to learn how these disks failed to give you like a heads up if something were to go wrong or about to go wrong. So let's jump into a demo. So I'm going to have Chris exit the share. And I'm going to go ahead and jump into the Azure portal, and I'll have Chris give me a quick, yep, we can see it.
Sure can.
All right. So welcome to the Azure portal. If you're not as familiar with this, this is where you would go deploy Azure services. And as Chris mentioned, AVS is a first-class, service in Azure. So everything for AVS is going to be done in the Azure portal when it comes to deployment and making sure it's connected, and some higher level, things that you would need like root level permissions to do, like changing cluster default storage policies. Everything else is going to be in vCenter. So if you want to find, the Azure VMware solution, if you just type Azure VMware, it's your first service hit. You can see we've got 3 demos across, the globe. We're going to use this West US location to start. And before I jump into the vCenter, I'm going to go show you those run books. They're going to be found down here under operations. And this is where you would go to say, update a storage policy. If you've gone, maybe you started with the first 3 nodes, you put some VMs in that cluster, and now you went to your 4th node. Now you can change your storage policies to RAID 5. To set any VMs coming into the cluster to default use that RAID 5 storage policy, you have to set the default storage policy for the data store, the vSAN data store. So if I click that, you can see it's just asking for basic information. So it asks for the cluster name, and then it wants the storage policy name, both of which you can get out of vCenter. And then you run that command, and it will go in the background and update that so that you now have that storage policy used as the default storage policy instead of that mirroring policy that it starts with. If you wanted to set, maybe there's some VMs you've already migrated into that 3-node cluster before it became a 4-node cluster, and they're already FTT1 mirroring. I can go set this VM storage policy, and it will allow me to change the VMs from RAID 1 to RAID 5. You know, the nice thing too is they still allow access to a lot of the APIs within vCenter. So if you're familiar with like the set SPBM entity configuration commands with PowerShell through PowerCLI, you could also code this yourself for the VMs, you know, if you want to change VM storage policies. So you do have access to do those things through the vCenter API. So, and then the last thing I'd say that we did discuss in our slides today is creating rules and alerts. So this would be the section where you could go create rules around metrics, and you will get some basic metrics for the service itself, as you can see here. So like if you wanted to do data store disk total capacity, and then make sure that you have a percentage threshold. So you get an alert to know, okay, we're starting to go up against that slack space number. Let's make sure that I go ahead and add a node to my cluster to alleviate some storage pressure. All right, so let's jump into vCenter, which is fairly easy. We just go into the VMware credentials and copy our vCenter IP address and pop that in. Our user credentials are going to be right here. And it looks like I was actually already authenticated for my last login. So, oh, no, it is going to prompt me for some creds. So let's pop that in. The cloud admin role is sort of like your highest root level permissions. It has certain things taken away from you that are within Microsoft's responsibility. So for example, you know, if you had full administrator of vSphere.local credentials, I could go right click a host and power it off. But with the cloud admin role, you can see you don't have access to that. So this cloud admin role is a special role that has certain permissions removed because it is a managed service, right? They are responsible for the hardware. They're responsible for the life cycle. So those things are removed, and that's why you have a cloud admin role. You don't need to solely rely on the cloud admin role. We do support AD authentication, so you can add an LDAP or LDAP-AS authentication source, but the cloud admin role is going to be sort of like the most high level of access that you will receive. And so you just have to keep that in mind. So let's go look at a couple of the vSAN capabilities from monitoring. You know, it's one of the things I mentioned as one of the best benefits of vSAN if you're not familiar with using the technology. So I can go to the cluster level and I can go down to performance, and this is going to give me a cluster level view. So every, you know, there's sort of a child-parent relationship has a monitoring aspect to it. The default view is going to show you the performance level from a storage perspective at the VMs level. So it's reporting what total IOPS the VMs are driving, how much throughput they're driving, how much latency is there. The backend is actually the backend IO, like we talked about with IO amplification. So you could see if you have, say, erasure coded VMs, or even just FTT1 mirroring, if you have a lot of writes, let's say if you had 100% writes, you should see about double the IO because it has to do 2 writes to make sure that your data is safe, right? So you can see all that information from the back end and the front end. You can go up to 24-hour views and show results. You can also pinch and zoom if you want to do that and get maybe read or write removed, so you can focus in on specific metrics. Again, a very robust set of monitoring tools here. If I want to go look at a specific host, I can just click on that host and look at its performance. So I can look at the VM performance on this specific host, or the VM level view. I can look at the backend level view, and then I can even get down to the disk group configuration which, the cache drive or the capacity drives to see how much performance is coming off of each of those. And I can even see things like cache, hit rates, et cetera, how much free write buffer percentage is available. There is a wealth of information here. I don't want anyone to feel intimidated by this data. It's just there for you to consume if you want to. At the end of the day, the benefit of AVS is that this is a managed service. What you really should care about the most is the highest level views of how are the VMs performing. So you can do it on a cluster host. Let's go see what kind of metrics are shown on the VM level. So I've got, looks like let's make sure to choose something that's on. So let's go look at my AD server here. You can see the physical disk placement. So, since we have a 3-host minimum setup here, you can see where those components actually reside, what host they reside on, and where the witness is. And this, goes back to my point of it's more like a RAID 10. You see how each component, this one happens to go across all the same, but they don't necessarily land like that every time. Like the witness just happens to land on the 5th host, but they can be dispersed out through nodes in the cluster. I can also go to the performance level view. If I pop open performance, it'll show me this VM's performance. It's an AD server that's used for testing mostly, so it's doing a whole lot of nothing. And then we see our latency numbers here too. If I wanted to look at individual disks, I think I've only got one here, but if I had more than one here, I could look at which ones may be causing the most issues and drill down to those specifically. So I've been talking a lot about storage policy-based management and the power of being able to choose different storage policies for even down to the same VM. Usually you're going to run one storage policy pretty much for everything, depending on your workloads. But let's say, for example, you have a database that has some virtual disks that need to be a mirrored policy because of the performance considerations. To change a storage policy, all you do is go into edit settings of the virtual machine. And you can see I've got 4 hard disks here. And if I drop it down, you can see the storage policy that's tied to these hard disks. So let's say that the hard disk 2 is my logging drive and it causes the most performance. So I could choose a mirroring policy, which be either RAID 1 FTT1 or RAID 1 FTT2. Those are the mirroring policies and the higher performing ones. I choose those for the hard disk 2, but for my other hard disks, I could go and choose RAID 5 and update those drives. Now I can't do that specifically in our environment here because we have only 3 nodes. So you have to keep in mind that there are minimum node requirements to do these setting changes. But the primary point to demonstrate here is that you can go change objects to different storage policies, even down to the individual VMDK. So I'm gonna go ahead and cancel out of that here. So I'm gonna go ahead and stop the share and I'll have Chris bring up our slide deck and we will actually go through a customer use case. And I've still got control here, so I'm going to move to the next slide. So we chose a customer use case. We're obfuscating a lot of information because they're not publicly referenceable. So what we're focusing on is an example to show good storage performance. And this is a very unique case that really drives storage performance that's not commonly seen. This is why this is such an exciting use case that I wanted to share. So what we can tell you is they're a healthcare provider, and their use case was to restore essential services in AVS should a cyber threat show itself. So the idea is if a cyber threat were to occur and maybe they lock up all our systems and demand payment in Bitcoin, could we restore an AVS within a certain amount of time? And the amount of data for essential services was 360 terabytes, and the recovery time objective was 8 hours. So this is a lot of data to restore within a very small amount of time. So for the tools needed to test this use case, so they wanted to see this done in the environment first before they moved forward with the solution. We deployed a 10-host AVS software-defined data center, so an AVS instance with 10 hosts. We used their existing backup vendor, which was compatible with AVS. And on our documentation, we show about a list of 5 to 6 backup vendors. So we work with almost all the major players out there. And then we also set up some things in Azure native like blob storage, because it makes the most sense from a cost perspective to store that backup data in blob storage and not necessarily manage disks. So that's sort of the setup that we have. Let's kind of look through like what a whiteboard looks like. So maybe this gives a clearer picture of the use case. So the idea is you go ahead and at least start with, you know, a 3-node configuration in AVS so that you have the plumbing there, because there's going to be some work done to stand up your network connectivity and your routing. Maybe you have a firewall to set up. And not only that, the backup tool needs to be able to connect to a vCenter to be ready to restore. All that work should be done. So you at least have a 3-node minimum already deployed, ready for this use case. And that's what we had for the customer. And so we follow the green line, you know, in a everything's fine time frame. We're backing up data across the express route, and we're putting it into the backup tool, which offloads the storage into blob storage. So that's constantly going based on, you know, whatever their recovery point objective is, or RPO, whether it's, you know, 4 hours, 8 hours. And the idea is if a cyber threat were to occur and suddenly everything is in a down state and we need to recover, now we want to be able to recover quickly through those backups that we have in Azure. So what we do is we have backup proxies that are in the AVS cluster, and we start rehydrating that data out of blob storage into the backup tool and rehydrate it into AVS. And so those backup proxies then take those backups and restore those virtual machines. And then we're able to get our tools and services back up so that the healthcare provider can continue operations. So what were the outcomes of that testing? Some pretty impressive stuff. We were able to get out of the 10-node a peak of 5.72 gigabytes per second of that restore. So we were able to peak out at 45 gigabits per second. I mean, that is a very fast restore rate. Now the IOPS are lower. Don't really pay attention to the IOP number because, again, this is a throughput type of test. These are large block sizes when we're talking about restores, and not small block sizes. If they're smaller block sizes, IO is usually the bottleneck. When they're larger block sizes, it's throughput that's the bottleneck. And so 45 gigabits per second is a very good number. And more than likely, our bottleneck was either possibly at the network or at the backup vendors level. We didn't really test different scenarios to see what the bottleneck could be, but vSAN was capable of even doing more. It showed that not every disk was stressed, and it could actually go even higher if needed. We were able to get that RTO in 6 hours, beating the 8-hour requirement, right? So we were able to meet the customer's objective for the cyber recovery in this solution. We did test different node types. We didn't really talk about node types today, but just to let you know, we have the AV36 makes up the large percentage of our fleet out there. There is an AV52 that's a bigger node, and we did test that, and it didn't show even faster throughput. So again, we believe that the bottleneck was somewhere either in the network or within the backup vendor's restore capabilities. So that really concludes our webinar today. You know, if you want to learn more, we do have an AVS team on YouTube. Definitely check out some of the stuff we post there. You know, work with Microsoft and your VMware team. You can pilot AVS and reach out to your account executives to find out more information there. We have a hands-on lab on the VMware hands-on lab. We have test drives and plenty of resources between Microsoft.docs.com and VMware documentation as well. So with that, I'll hand it back over to Chris to kind of wrap things up.
Thanks, Matt. So to conclude, we thank you for your time today. And as Matt said, if you have any additional questions, there are a ton of resources available to you. You mentioned the hands-on lab. There's one for provisioning the Azure VMware solution. There's one for migration with HCX. Highly encourage you to check both of those out. We'll continue to update additional content both to the YouTube channel and these ongoing webinar series. So we thank you and I wish you all a happy day.